Really trick you up if you're not careful. We're basing this deep dive on a great Medium article by Genohu Abbey 1R called Avoiding Common Rust Mistakes, Sentinel Values and Effective Enums. And really the goal here is to see why these little things, they seem small, but they make a huge difference in writing good, clean, solid Rust code. Right off the bat, the article jumps into Sentinel values, which, let's be honest, we've probably all used at some point.
Yeah.
Like using -1 for someone's age when you know age can't be negative, or some weird temperature to flag an error or something.
Yeah.
Have you ever run into those in your work, and what kind of headaches did they cause?
Oh, absolutely, yeah. I remember this one project, we were pulling data from a bunch of different sensors, and one of them, every so often, would just spit out these crazy temperature readings, like way outside the normal range.
Oh, I bet.
Yeah. So to deal with that, we initially used NECIS 999 as like a sentinel value,
Yeah.
Figured that's a pretty clear sign something's off.
Yeah, it seems like a quick fix, right? So what happened? Did that magic number come back to bite you later?
Oh, it totally did. At first, it seemed fine, but as the code base grew, it got harder and harder to remember that magic number everywhere. Like we had to keep it straight across different functions, and someone would inevitably forget, and then boom, wrong calculations, weird bugs, just a whole lot of confusion trying to debug.
Sounds like trying to find a needle in a haystack, except the needle is a random negative number messing everything up.
Right, exactly.
So how does Rust deal with this? The article mentioned the option enum. What's the deal with that? Is it kind of a built-in way of saying, hey, there might be something here, or there might be nothing at all, you figure it out?
Yeah, that's a really good way to put it. It's like checking your mailbox, right? You don't just assume there's always mail in there. You're prepared for either a letter or for it to be empty. Option in Rust is kind of similar. It gives you the safe, explicit way to deal with values that might be missing, and it does that using two variants, some value and none.
Okay, variance, that sounds interesting. So some value is like, you've got mail, and none is like empty mailbox. Gotcha.
Exactly.
But how does that actually work in the code compared to, say, using your NA999 Sentinel value?
So going back to my sensor problem, instead of returning that NA999 for a bad reading, we could return an option F32, where that F32 is our temperature value. If the sensor reading is good, we return some temperature, holding the actual temperature, and if it's out of range, we just return none.
So instead of remembering an arbitrary number, you have this clear, self-documenting way of representing no data. It's like saying, hey, this sensor reading, totally optional.
Right, exactly. And the really cool part is that the compiler then forces anyone using that code to acknowledge that the value might not be there. They have to handle both cases, some and none, which makes the code way more robust and less prone to those weird surprises we talked about.
No more hiding behind cryptic Sentinel values. By using option, you're like, okay, missing data, I'm ready for you, and writing code that's way safer and easier to understand. Sounds like a win for everyone. All right, so we've banished Sentinel values to the shadow realm with the power of option. But this article doesn't stop there. It dives into another common Rust pitfall, not fully embracing the power of enums. You see, coming from other languages, I used to think enums were just glorified constants, a way to give names to numbers, but not much more. Is that how Rust rolls, or are we talking about something much cooler?
Oh, we are definitely talking about something much cooler.
Okay, good.
In Rust, enums are like supercharged data structures almost. They can hold data. You can have methods attached to them. They can even model complex state transitions. It's a whole different ballgame compared to those, simple enums you might find in other languages.
Okay, now you've got my attention. The article uses the example of representing user roles like admin, user, or guest. And I'll confess, I've totally used strings for that in the past. But it sounds like Rust has a more elegant solution up its sleeve.
It absolutely does.
Okay.
While using strings might seem convenient at first, it can actually lead to a whole bunch of problems down the line, especially in a language like Rust that's really big on type safety.
Okay, so walk me through this. Let's say I'm building a system with different user roles, and I decide to stick with my trusty strings. What kind of havoc am I about to unleash upon myself?
Well, first of all, get ready for a world of typos.
Oh, no.
Imagine accidentally typing like add instead of admin. With strings, the compiler's not going to catch that, and you're going to be left wondering why your authorization logic is going haywire. And it gets worse. Because you're using strings for this, you're going to end up with code for handling these roles scattered all over your code base.
Oh, yeah. I can see that
But
happen.
you need to add a new role. Good luck hunting down every single place you use string comparisons. It's a maintenance nightmare.
Yikes, that sounds like a recipe for disaster,
Mm.
especially as a project grows. So how do Rust and its amazing enums save the day? Give me the antidote to this string-based chaos.
Okay, so instead of relying on these like error-prone strings, imagine this. You define an enum called role, and it has distinct variants for each role: admin, user, and guest.
Ah, I see what you're getting at. So by using an enum, we're creating these clear, distinct types for each role, not just strings that could be anything. But how does that actually help with the issues we talked about, the typos, the scattered logic? How does that all fit together?
Let's break it down. First, type safety. With an enum, the compiler becomes your best friend. Try to sneak in a typo like, and the compiler will yell at you.
They'll be like, nope, not going to happen.
Exactly. It'll say, hey, that's not a valid role. No more typos slipping through the cracks.
I love it.
Second, centralized role management. Your role enum, that's the single source of truth for all roles in your application. You want to add a role, you want to modify a role, you only have to update it in one place.
It's like having a neat and organized control panel for all your user roles instead of just like loose wires everywhere.
Exactly.
But there's one more thing the article mentioned that I wanted to touch on. Exhaustiveness checking. That sounds pretty intense. What's that all about?
Ugh, exhaustiveness checking. That's one of my favorite things about Rust enums. Imagine you add a new role, let's say moderator, to your role enum.
Okay.
Now, let's say you forget to update some part of your code that uses the role enum to handle this new moderator role.
Uh-oh.
In many languages, this could lead to, like, subtle, really hard to track down bugs, but not in Rust.
So Rust is going to save us from ourselves again.
Exactly. Because we used an enum, Rust's compiler will do something incredible. It'll throw a compile time error saying, hold on a second, you haven't handled all the possible cases of the role enum.
Wow, that's incredible. It's like having like a super-powered compiler looking over your shoulder, making sure you haven't missed anything. No more sneaky bugs slipping through just because you forgot to handle one little thing.
It's a beautiful thing, isn't it? That's the beauty of this exhaustiveness, checking with enums. It just adds this whole other layer of safety and robustness to your code.
I don't know about you, but I am amazed. We've gone from these little sentinel value gremlins to the elegance of option, and now these powerhouse enums that are like, they've got your back.
Yeah.
So to wrap things up for our listeners who are ready to level up their Rust game, what are the key takeaways here? What should they really remember?
Well, first and foremost, ditch those sentinel values. Seriously, say goodbye.
Out they go.
Embrace the power, the clarity of the option enum. It's all about handling those, maybe there's something there, maybe there's not situations explicitly, right?
Yeah.
It just makes your code more reliable and way easier to understand.
It's like, hey, I'm not afraid of missing data.
Exactly. And never underestimate the power of a well-crafted enum. They're not just for, giving names to things, they're for creating safer, more expressive, more maintainable code. Use them, model different states, represent complex data, just, take advantage of all that amazing type safety that Rust gives you.
Beautifully put. This whole conversation has me thinking about like all the places in my own projects where I could be doing things better. It's like we've unlocked this new level of coding wisdom. So here's a little something for everyone listening to chew on. Take a look at your current code or that project you're about to start and ask yourself, where can I use option to handle those maybe, maybe not situations more gracefully? And how can I leverage enums to bring more structure, more clarity to my code? Trust me, once you start thinking this way, you'll wonder how you ever wrote Rust without them. And on that note, thanks for joining us for this deep dive into avoiding common Rust mistakes. Until next time, happy coding.